end up with so much data, but making sense of it is what turns it into intelligence. So now we're getting the tools to do that. I want to come to our chip maker next about what is the potential for dramatic reductions in or increases in efficiency. Now, where can we find solutions in terms of energy and infrastructure inputs into AI? But before that, I just want to follow on from the comments we had just now. There was another area which has become politically very sensitive, which is water consumption. Another one of the areas that doesn't get as much attention as it should. But here too, there are misperceptions, and there's best of class behavior, and there's laggard behavior, right? Some of you who are keenly sighted will notice that I'm wearing boots. High boots. The last time I wore these boots to Davos, but the last time I wore them was in Abilene, Texas, because I had been invited to get a tour of Stargate at the world's largest AI complex, led by Sam Altman on that example. And they told me, if you don't wear high boots because of rattlesnakes, we won't take you on the tour. So I immediately went and bought, as strong and high a boot as I could get. And now these sands are mixing with the snows of Davos. I imagine there are rattlesnakes here of a different sort. I'm keeping my eyes open for this. But the reason I mentioned this is when I toured, the night before, I like to talk to the locals, and they have their happiness about having jobs, but they complain about this and that. Rents are going up, fair enough. Jobs are coming, yes. They said, but they're going to take our water. This was the #1 complaint. All these data center guys, AI is going to take our water. And I was told from an old timer, in Texas, whiskey's for drinking, water's for fighting. Yeah. And they were ready to fight for their water. But what I saw when I went on the inside of the tour of the first of their 9 data centers that they've already built up was actually NVIDIA chips, water-cooled, immersed, like the kind of technology I saw at your facility in Italy. So I was quite aware of what I was looking at. And this facility, entire in the aggregate gigawatt scale, will consume about as much as one American household, 1 or 2. And Microsoft has just made an announcement a couple of days ago. They're going to be net contributing in terms of water to the community. So if you choose sustainability from the beginning, if you choose to think about efficiency, again, that end game, where you want to be, as Wayne Gretzky put it, he skates to where the puck is going to be, not where it is today, then it is possible to achieve some of these other objectives. So with that in mind, we look to chips, we look to the efficiency and the demands that we know that they're going to rise, but what can you give us in terms of hope about how to think about designing for the future, designing with sustainability in mind?
Sure, thank you for the question. So 15 seconds on ARM. We're a provider of the most ubiquitous CPU ever invented in mankind. The CPU is the digital brain of every single device. I can assure you that everybody in this audience has not only one ARM processor on them, but probably dozens. ARM is the CPU that powers wearables, smartphones, cars, PCs, and data centers. We have a unique view of the world, and today we are the chief CPU in all of NVIDIA's Grace Blackwell and Vera Rubin technologies. The Secretary made a very interesting comment about how difficult it is for governments to sort of skate ahead of the puck here. Even for chip makers, it is hard. But I think the opportunity that's been untapped is running AI at the edge. And what does the edge mean? The edge is your smartwatch, your smartphone, your PC, your security camera. Today, virtually every single piece of AI processing takes place in the cloud, every single one. That is, in of itself, is not sustainable for the reasons that we have talked about. The game has not yet started relative to running artificial intelligence on the edge devices. And you might ask, well, why is that? I mean, it's a known problem. Actually, not so much. If you think about Gemini Nano, which was introduced about a year ago, that was put into a smartphone, the Galaxy S25. The chip that was designed for the Galaxy S25 was designed 2 years prior. The processor that was defined to run that AI workload a year before. We were shooting at the puck in 2025 with a 2022 design. Impossible to run that at the edge. I believe there are going to be breakthroughs in the next number of years where you're going to see a distributed computing model that will make this far more efficient. And we've seen this movie before. If you go back in time to mainframes, or people who would go to university and all the computing would have to take place, you'd have to be in the college campus at the workstation, and then PCs, smartphones, et cetera, et cetera. AI is moving so quickly, and the sheer amount of data required, it's going to require a level of innovation that we haven't yet seen. Advanced memory technologies, packaging, materials. How do you put all that AI processing into something that fits in your hand and your hand doesn't melt? But I'm very optimistic we're going to solve that because we've seen that movie before. And when that happens, I think you'll start to see a big change relative to the size of these data centers and every single AI workload having to run in the cloud.
Sure. For those who are aficionados, there'll be the immediate challenge. There's a Jevons paradox. There'll be some rebound effect. But I think we've seen with the internet and multiple other examples that that's a great race. And we can win that race with continued acceleration, innovation, and making efficiency of use a priority, which sometimes it's not. Right. Governments have talked about, and the IEA has had a formal efficiency target for energy that has consistently not been met, right? So it tends to happen bottom up rather than
been in semiconductors for 40 plus years.
Right.
We're seeing a big memory shortage today in terms of running these models. Shortages are the necessity of invention. And when you see the kind of problems that we're facing, the technology, companies tend to rally around fixing these problems. And again, I think we've seen this movie before. I don't want to say it's an easy one to solve because the scale of data that we talk about with AI is unprecedented, but the industry is quite focused on it. And at ARM, we're very, very deeply involved in it.
Good. You mentioned scale. It's a nice segue to our next panelist, Josh. At N scale,